Let's talk about Amazon VPC now. I'll try to explain this thing from console and from slides so that it would be much easier for you to understand. Now, first thing about Amazon VPC, it is an isolated network and it exists within a region. So let's consider this is a region, and whatever I would create, like whenever I would create a VPC, its boundary would be a region. It won't be going beyond a region. So that is one thing, right? I'll first go to the console and show you some details, and then I'll keep on coming back to the slide to bring home some of the concepts here. So this is my AWS management console, and I am interested to visit a service here which is VPC, Virtual Private Cloud. It says isolated cloud resources. So that's what we want to build. We want to keep our resources isolated. Now, to facilitate you to get started faster and without worrying about networking, what AWS gives you, it gives you a default VPC in every region. See this? So this is my region, resources by region. I'm on VPC dashboard and I see US East which says one VPC. And if I click on that, it would tell me the name, which is not there by default. There would be a VPC ID, a unique identifier, status of that, then which IP address range it is using, IPv6 CIDR if I'm using IPv6 addresses. Then I have DSCP, a route table, and network ACL, tenancy, and default VPC. This is what information is there. So this tells me, hey, this is a default VPC in my Northern Virginia region. Similarly, remember this VPC ID, which is one last C20. I would, let's say, go to Ireland and see if there is a VPC existing. By default, every region would have a default VPC, and if you do not want to get into details of network configuration, you could use it. But most of the time, enterprises would configure VPC as per their own requirement. Now, this one is Ireland is ending with F5B, but it has the same IP address range and additional information associated with it. What my requirement is, I want to start by creating a VPC. So let's create a VPC into Ireland region as of now. So I'll go back to my VPCs and I would see the VPCs here. I would say let's create a VPC. VPC creation is very easy. There are two options now to select: VPC only or VPC and more, because it would require additional resources like subnet, route table, security groups to be created within it. Right now, to explain things one by one, I am creating a VPC only, and let me call it my VPC01, and let me make identifier here Ireland. Now, I could go ahead and say how my IP addresses would be assigned to the VPC. That I would be using a manually provided input for CIDR range. CIDR stand for classless interdomain routing. This is a way of representing IP addresses. Now, just a quick summary of how this thing actually works. So CIDR represents that which bits represent a network address. Like if I'm taking this particular CIDR range, in this it says which bits represent a network address and which bits represent a host address. That's what we are looking for here. Now, think about this network address and host addresses. Like, let's say you have been given a task that, hey, there is a big building and you have to assign some addresses to this building. This is a building and there are floors on, let's say, a big hotel, and there are floors here into this building, and on every floor there are rooms where you can go and stay, right? Now, probably this hotel would have some naming convention or numbering convention, probably that would be this is ground floor, or let's call it, let's say ground floor is parking and it is 1, 2, 3, 4, 5, and 6. 6-story hotel, and every floor has, let's say, 20 rooms. Just give an example. Now, if I want to represent these rooms, maybe the best way to represent it would be that I take a 3-digit number for representing every room, and in that 3-digit number, I keep the first digit for the floor number. So if my room is on floor number 3, my number would start with 3 and then remaining would be, let's say, room number 18, so that is 318. So in this number, the first bit is representing the network address or representing the floor number, and the last two bits here are representing the hotel room in that particular floor. Now, if I have taken a 3-digit number, then I have fixed that I would be using the first bit or first digit for the floor number. That would mean the maximum number I would be able to create here will be 999, and if I can't use a 3-digit number now for a hotel which has more than 9 floors. So in that case, what I would have to do, I would have to add one more digit here so that now I could represent up to 99 floor hotels. And if you're referencing to a hotel like Burj Khalifa or a place like Burj Khalifa, which is 150 floor, this naming convention of keeping 2 digit for your floor and 2 digit for your apartment number within that floor may not work. Maybe we may have to look for a solution in which there will be 3 digits for floor, and maybe each floor has 100 plus apartments. So maybe we would need 4 digit to be kept for the apartment numbers there. Let me now relate this knowledge back to our this IP address, which is 10.0.0/24. Now this 10.0.0/24 is representing here that out of the total 32 bit, first bit is 10, second is this 10.0, second octet, sorry, third octet is 0, and then fourth octet is 0, right? And we want 24 bits to represent the network address. So trying to draw this thing again, this one represents 8, right? Let me clear this and draw this thing again. This one represents 8, again 8, again 8 here, and again 8 here. So when I say 24, that means 8 bits, 8 bits and 8 bits here, they represent a network portion of the IP address, and the remaining 8 bit of this total 32-bit number is representing the host address here. So this will be a well-suited network when I have less number of hosts and I have more networks. This time that is a better approach. But what if I have created a IP address in the range 10.0.0.0/16? So when I say /16, that means the first 16 bits would be representing the network portion, and the remaining 16 bits would be representing the host portion. So that would mean I have more numbers here available for my host, and that would come out to be how many hosts. So 2 to the power 16 hosts I would be representing through this IP address range. I would have more number of hosts accommodating into this IP address range. So what I want to do, I want to create a VPC which will give me some room for future expansion, because this cannot be changed after the VPC gets created. If you made a mistake here, you may have to create another VPC or may add another CIDR range to the VPC. I'll explain what I mean by that. So let's keep it simple. My requirement is I want to host a VPC with the IP address range of 10.0.0/16. This is my CIDR notation. Do I need IPv6? Keeping things simple, I do not need IPv6 probably as of now. I would use tenancy default, any tags which we have already configured, and I just say create a VPC. So what happened now? AWS has created a logical boundary for me, and that VPC got created for me as we see here. Now, I just created a VPC, but behind the scene, some additional components got created for me. So as soon as I create a VPC, yes, VPC gets created, but one more or few more things get created for me. One of them is DSCP option set. I'll talk about each of them one by one. So I automatically get a DSCP option set configured. I automatically get a main route table configured. I haven't said that, but it automatically is getting ready for it. And we got a main network ACL automatically deployed for me. One more component gets ready here, that is called my security group. It is not default displayed here, so we may have to go further to check that. Let me navigate to security groups here and let's find out if we got a security group created or not. So see this one. This is a VPC which I have created. VPC 19BE. Let me quickly confirm that we are referencing the same one. I go back to VPC and see this is 19BE. And if I go to the security group, I get a default security group created for my VPC. So these four additional things automatically gets created as soon as I create a VPC. What is the use of these? DHCP option set is to allocate or auto allocate IP address. My machines, when they boot EC2 instances or RDS databases or any type of component which runs within a VPC, they would need an IP address and that would be provided by this DHCP option set. If I want to change this, I can. Route table, basically it is a navigation for my packet, that how they would go from point A to point B, that is defined by the route table. Network ACL is a security at subnet level. I'll explain this in detail. There would be a separate section on network ACL and security group, but it is security at subnet level. I haven't explained subnet. I'll come back to that in a minute. And security group is basically security at instance level. That is four component getting created for me, right? Now let's go ahead and see what else we can do once my VPC is ready. And if you remember, I created my VPC with 10.0.0/16 as the CIDR range for my VPC. That has been created. This is a big space which is given to me, which can have up to 2 to the power 16 host. Probably I would like to create logical separation in that. If you remember my example that you have a big room and in which thousands of people are talking to each other, there would be too much noise. So what we may want to do, we may want to logically create isolations here so that only the required people can communicate with each other. So within a VPC, what we create something called a subnet, which is a logical isolation and which will use a range of IP address from this bigger chunk. So let's say this is a bigger chunk of IP addresses. When I create a subnet, I would use one portion, second portion. Similarly, I would be dividing my IP address range into smaller portion. So we'll see that in a minute. Now, let me go back to my PowerPoint. What we had, that we had our VPC in this region. Now, region has availability zones, right? When you create a VPC, it is an entity which exists into a region, but it can span across multiple availability zones. Now, for sake of keeping things simple here on the slides, I am representing only two availability zone, but technically it would be having multiple availability zones. So VPC is a regional entity, but it can span across availability zones as we see. And once I want to start using or build component inside, I have to start by creating something called a subnet on that. Subnet is the logical portion on which my resources would be added. Now, resources, whenever I say, most of the time we would be adding a EC2 instance into a subnet. So instance cannot directly talk to a VPC. Instance first has to be attached to a subnet, and then my VPC would be allowing communication across subnet. So subnet exists within a availability zone. I can create a subnet called public. I may create a subnet called private, another subnet called public into AZ2, another subnet called private into AZ2. That's how I can do. Right. So let's go ahead and create this. What subnets are? Think of subnet like a wire, a network cable, which is within that network of availability zone 1. Obviously, we don't want to create a network cable like this because then it would add lot of latency to my workload. That's why a subnet exists within the boundaries of an availability zone, and that is basically a wire on which we would be attaching our EC2 instances. So let me first create this architecture of subnet. Now I want to highlight some IP addresses here. Let's read this IP address here, which says 10.0.10/24. So I've got a bigger IP address range /16. I have further divided that. So in 16, I have 16 bits for my network and I have 16 bits for my host. So this is representing my network bits and this is representing my host bits. But this is a too big network. So what I do for subnet 1, I say, okay, I would use you in 24 slash notation, which means I would use 24 bit for network and I will use 8 bit for host in my network. Same way subnet 2 here. This is again 10.20/24. So 24 bit is reserved for network and remaining 8 bit is reserved for the host addresses. Let's go ahead and implement the same thing in our AWS console. So what I would do, I would now go ahead and create a subnet inside my VPC. So this is my VPC. This has been created. There are no subnet in this VPC. Let me do one thing. Let me rename the first one as a default VPC so we don't get confused with that. This is my default VPC which AWS provided me, and my VPC 01 Ireland is what I have created, and I am interested now to create subnet here. See this? I have no detail of subnet here. Subnets are created in this section here. So I'll go to subnets. Now I already have 3 subnets here. And if you look further, these subnets are from VPC default. And why 3? I am into Ireland and Ireland has 3 availability zones. So default VPC has a subnet into each availability zone, as you see here, 1A, 1B, 1C, and we can then host our applications here. Right. So my interest is now to create a subnet. So to create a subnet, I have to tell which VPC it would belong to. I would select this VPC. I would be keeping things here. And then I could add multiple subnets here and can give them name. What I would refer, I would be using a specific IP address range. I would use one subnet in AZ1, which will be 10.0.10/24, and then 10.0.11/024 that would belong to availability zone A or availability zone 1. So let me go ahead and create it. So I would call it public. Why I am calling it public, I will tell you. And let me call it, this is into AZA. I would keep it into 1A. I would give it the IP address of 10.0.1.0/24. That is the first subnet, which I am calling public AZA. Then I could add another subnet, and let me call this one private AZA and keep it into the same availability zone 1A, and this time IP address I'm using is 10.0.11.0/24. Right now I have just created 2, and what they are representing 2 subnets within the VPC of my choice, and they are into the same availability zone, but I have renamed one to public and one to private. Why I have done that, I'll explain that. So this is what I have created so far, a public subnet with this IP and a private subnet with this IP. The next thing I would do is repeat the same subnet creation but into availability zone 2. Be mindful here that I cannot use the same IP address which has already been used. So I have to change the IP address here, and then I would be able to create subnet into AZ2. Also, let me go ahead and say create a subnet, and this time I want to create it into Ireland VPC. Then subnet name, I would call it public AZB, and that is my 1B reference here. I would provide an address here. Let's say I go ahead and try with 10.0.1.0/24, Let's see what happens if I say create a subnet. See this? It says CIDR with this IP address range already exists, so I have to change this. I would change it to 10.1.2.0. One subnet which is called public AZB, I would add another subnet and I will call it private AZB. I am keeping that into 1B. Let me quickly check if I have kept it into 1B. Yes, 1B, and this one is also into 1B, and this time IP address I am using is 10.12.0/24, and once this is there, what I have achieved so far, 4 subnet, two are called public, two are called private, and they all exist into two different availability zone. So total 4 subnets have been created by this method, what I have done so far. Now, there may be so many of them, so I could go here and say, hey, I want to filter based on this VPC 19BE, and it would only show me the subnet associated with that. And here you could verify 10.1, 10.11, 10.2, 10.12, and which particular availability zone they belong to, right? Now, one more important aspect here is to understand that what are available IP addresses. Here it is 251 available IP addresses. What is the meaning of that? Now, if I do a simple math, how many IP addresses would I get with a /24 mark? Let me go ahead and write that. So let's say it was 10.0.10/24. That means I have 24 bits for network and the remaining 8 bits are for my host IP address. Host means your EC2 instances or any component which would need an IP address on the subnet. So total I could have here is 2 to the power 8. So sorry, 2 to the power 8 is how many total IP addresses would be available, which comes out to be 256 IP addresses. But AWS reserves some IP addresses for its internal purposes, and some are reserved by default by some service, by some method how TCP/IP actually works. Like you can have any phone number. Let's say you want to have a specific phone number, but depending on the country, like if you are into UK, you can't say, hey, I want to have a phone number which is 999. This is here in UK reserved for emergency services. Similarly, if you are into US, that number would be 911. You can't have this number. Has a significant meaning. It has a very specific meaning when somebody dials this number. Same way if it is in India that number is referred as a number called 100. So it depends on where you are, and these numbers cannot be used for general purpose. They have a very specific purpose. Similarly, out of these 256 IP addresses which are available, there are 5 IP addresses which you can't use, so that gives you 251 valid IP addresses to choose from. I'll tell you where these IP addresses are used and why you can't use them, but by default you will get whatever you create into subnet minus 5 IP addresses for your workloads to run. So be aware about this when you design your subnets. Right. So this is my 256 available IP address. Let's go ahead and quickly search for Amazon VPC reserved IP addresses, and you would know that which specific IP addresses are reserved and what are the use of those specific setting. I will put this link into chat, sorry, into resources, so you would have access to those specific IP addresses. See this one here. Yeah, this one. So first IP address of any subnet you create. Here my subnet is 10.0.0/24. So first IP address will be used for network addresses. The second IP address, which will be referred as the first .1 IP address, is reserved for the VPC routing. All the routing logic is going through this IP address. Second one, here 10.0.0.2 is used by AWS DNS server. So DNS is a way where you can refer to an instance by its name rather than IP address, and that service runs on 10.0.0.2 IP address. And then 10.0.0.3 is not currently defined, but they kept it. Maybe in future there would be a service which would require it, so they have kept it reserved. And the last address is a network broadcast address which cannot be used also for assigning to your host. In your physical world, first address 10.0.0.0.0 of that subnet, the first address and last address can't be used. Apart from those two unusable addresses, AWS reserves three more IP addresses. So total IP address you could use in your environment is 251. All right. So I hope this thing is clear, that how we have created a VPC and how we have created a subnet inside it. So far we have achieved this. And once this is ready, we could start hosting our applications here or my instances here. So my EC2 machine, when I would go through launching, I would be able to select which subnet it would belong to, what would be the subnet it would reside into, which VPC it would belong to, so I could keep on adding resources in my environment. Let me quickly go through EC2. I won't deploy an instance, but I will just show you the option that how I could select a VPC and a specific subnet to launch my EC2 instances now. Because I have created a new VPC in my environment. I do not have any instance running, but I would quickly go through launch instance. I want to launch one. I'm happy with keeping the default information. Let's call it web. And I am more interested in this setting, which is network setting. See, if I do not say anything, it will go into default VPC and it will auto select a subnet for me. But if I want to be selective here, I could say, hey, don't go into default VPC. I want this instance into my Ireland VPC. Plus, I want it to be hosted into a specific of my subnet, which is AZA, AZA or private, and then private AZB, public AZB. You could select any of them, and then you could deploy your EC2 instance. I could also say auto assign public IP, so I'll talk about public IPs in some time. But what we achieved so far, we have achieved a VPC with some subnet inside. In the next chapter, I would explain about the concept related to route table, internet gateway, and net gateway. So I hope you are learning something new. If you have any feedback, feel free to reach out to me on LinkedIn and I would be happy to listen to you, maybe have a one-to-one call with you if you have any feedback or any questions, and then we can take it forward. So enjoy your learning. I'll talk to you into the next section. Thank you.